Hi everyone, in this video we are going to talk about a new package called lubridate. Lubridate is not a package in tidyverse because it mainly deals with days and times. And you can see this is a cheat sheet about lubridate. It can help you deal with days, time, year, month, the day, even hour, minutes, and seconds. So it is a very helpful tool. It can even help you check the time zone and change the time zone. Or you can do calculations with date and time. So it's a very helpful package, and we are going to talk about the basics of this package. So this is my RStudio. I'm going to create a new R script. And first thing first, if you haven't used lubridate before, you want to type install.packages. Within that quotation mark, you type lubridate and run that so your package is installing. And once the installation is done, you can run the library function on that package so that you can load that package for use. So you can see the library, there is a warning, but there is no error. And the two other packages we may use today, one is called tidyverse. If you haven't installed it before, you may install it in the same sense. And another package is called NYC Flights 13. So to get the package ready. And our topic is for creating or dealing with days and times. So that's our title of the day. And then what we are going to do is to go through some basics of creating days and times. And then we are going to check, like, what if you have a real data set that is not really what you want? How can you extract the time information or even create the time information from the information that is given to you? So the simple thing is to use today function. So if you run that, you are going to get the date for today. And even you run the now function, you get the date and the time and also the time zone. So those functions are very simple and very basic. And to create a time variable, you may want to create from strings, or you may want to create them from unquoted numbers. And there is another way is to create from a data set. So these are the three ways we are going to go through. And the first way is to create it from strings. So one thing you can do is to use the quotation mark because they are strings. And then you type a date. Within that quotation mark, you can see this is YMD, year, month, day. So if you run that, you are creating an input for the date. Or you can do month, day, year, and add the quotation mark to make sure, and then you can type November 24 and then 2021. And you can see this is the same date you are creating. And you can also type the first three letters of the month and you will get the same thing. So you can see it is a little flexible there. And we can also use day, month, year. So you can see you can change the how you are going to type it. You can type 24 November and then 2021, and you are going to get the same. So you can, it's it is kind of flexible there. You can do different ways. But all your input, you're putting the same format in R, no matter which function you use and which format you are using to put the data in. So when you use unquoted numbers, you can do something like year, month, day. Similarly, you can use YMD, MDY, or DMY. But these are unquoted numbers, so you shouldn't use quotation mark within it. And then you can type something like this. It will give you the same thing. So if you are actually putting the days in manually, maybe this is the easiest way, because you are not typing the quotation marks. You just put the numbers in according to the function that you're using. And there is a more complicated function called year, month, day. You can see here hour, hour, minute, and hour, second. So if you use hour, minute, and second, then you can do something like 2021 November 24, and after that you can type the HMS. So suppose it's 10:30:59, and then you can write, and you can see it is showing me by default the time zone is UTC. And you can actually change the time zone in the function, but set it as time zone TZ equals maybe EST, Eastern time. Yep, just like that. The third way we are going to talk about is to create the data formats or the data the days information from a given data set, which is the situation here when you have the flights data set. Remember, you can actually check the data set using capital V view function, and you can see this is a very large data set including a lot of time information: departure time, scheduled departure time, departure delay, arrival time, scheduled arrival time, and so on. A lot of, and even hour, minute, time, hour, all those information there. So this is a very nice data set for us to use the data, to use the lubridate package and to create days and time. So the first thing I want to use is to create a date time using the year, month, day. You can see all those information are given separately: year, month, day, and in the end I have hour and minute. So my first question to solve here is to create date and time from the separated information. So flights, and remember you have loaded the package called tidyverse, because right now we are actually using dplyr from tidyverse package. And then you can select. The variables we are selecting are year, month, day, hour, minute, and that's it. So you can see we have YMD, H&M. And then you can create the time information using these all together. So you can add a pipe and then you can mute it. So right now we can use muted to add a variable called departure. And then we can use a function called make date time. So you can see the explanation here. It is a function that can help you assign the year, month, day, hour, minute, second, and so on. So you can actually use those information to combine the date and the time together. So you can either copy everything here, put it into the parentheses, or you can just type it. And then you can just run this, and you can see the data set we have. We have year, month, day, hour, minute, and departure, which is the combined information from the first 5 variables we have. So now that is a single date time record. And the next one we are going to use is to think about the departure time and arrival time. Like, what if the data is given in a very strange way? Let's look at the flights data set. And if you look at it here, the departure time, arrival time, the actual departure and arrival times are in a format of hour, minute, or hour, minute with the local time zone. So you can see, if you check the flights, and then if you look at the departure time, you can see how they are recorded. So let's not do it this way. Let's just run this. And let's look at the data here. So you can see this is 1751. That means 5 p.m. 51, 5:51 in the afternoon. So they are all recorded in the formats by listing the hours in the first place and the minutes in the second place. So you can see these are the data we have. And if you want to know the exact departure time, minute, you shouldn't use this information there, right? You cannot like calculate the actual like the actual departure delay from like the departure time subtract the scheduled departure time, because how can you subtract 2240 with maybe 2040? And that's not the real 200 minutes. That's actually just 2 hours. So what I'm talking here is this. Because the departure time and the scheduled departure time, they are recorded as hour, and minutes. So 2 to 40 means departure at this time. And if you have a scheduled departure time, which is in the similar format, and if it is noted as this, that means the scheduled departure time is 8:40 p.m. And if I want to calculate the delay of departure, I shouldn't do this, subtract that, because that gives me 200, which is not the real delay. The real delay is just 2 hours, which may be noted as 120 minutes delay. So you cannot do such calculation when your data are recorded in this format. So now we are going to change that. So if we want to really calculate departure delay, I know departure delay is actually included in the data, but what if I want you to calculate the departure delay by yourself, right? Departure delay time. how can you calculate it? How can you calculate it from departure time and scheduled departure time? So you know what we can do is to change the format of the time. We want to change them into the real date time variables, and so we can do some math. So okay, what we can do, so this is actually our second question to solve. Solve the problem like you want to do the right math for calculating the departure delay based on the departure time and scheduled departure time. So first of all, let us talk about something. So you know, x divided by y, that's the division, right? You can actually calculate 100 over 10, which will give you 10 for sure. And if you do at 100 double percentage and then with 10 you get 0, because that notation, the double quotation mark, is giving you the leftover part after you divided 100 by 10. So same thing here. If you look at 2240, if you do the double percentage mark, here with 100, so that you know anything that is left, the result of it is the minutes. And if you do quotation mark divided by like 2240, quotation mark divided by and quotation mark, you are getting the hours. Because the specific notation in this data set, you are able to extract the hour in this way and minute in this way. So now let's do it by changing the departure time and scheduled departure time into the exact time in hour and minute. So we are going to do flies and then the pipe, and we are going to use mutate because mutate is for creating new variables based on the existing variable in the data. So I can call it departure time, which I name it as new because we are creating some new variables here. And then we are creating the hour and minutes from the existing variables we have. So if you are not familiar with the variables you have in the data sets, you can actually run the names function, and then you can see all the variables are there. And we are creating the departure time new from the real departure time that is recorded in this way. So what we are going to do is to use make date time, and then let's put the year, month, day information first. And then we are using departure time double quotation mark with 100, which gives us the minutes, right? It's like here. And then another one is departure time percentage divided by percentage over 100, which gives us the hour. So we want to put the hour in front of the minute, and we are getting year, month, day, hour, minutes information. And that's it. Same thing, we can write the scheduled departure time, which is also a newly created one, and we are going to make underline date time, and what the variables we are using here is actually the scheduled departure time. So I often go back to the variable names in the data set so that I will not make a typo. or an error because I typed the wrong name. So it is like this, hour and minute. And then these are the two variables we are creating. So you can just run this and you can see there is no error, but you're not seeing all the variables listed out. The two variables are added in the end. So one thing you can do is to add another pipe, and then you select the variables you want to have. For example, you may want the origin, destination. So right now, I also want to go back to the variable names so that I will not make a mistake. Origin and destination. And then I'm selecting the time. So because I named my variables ended with new, so I'm going to select the variables ended with such characters so that I'm selecting them out. So this is my newer data set, and you can see I only created a data set with 4 variables: origin, destination, departure time, and scheduled departure time. So you can see the time is in a very standard format with hour and minute information. And you can also name that data set as flights delay, because we are actually talking about the delay information. And this data set is now created. And to do the math calculation, let me put this on top. So to do the calculations, I just need to do one thing. So I can use the flights delay, the newer data set, and then I use muted again, because I'm going to do the math calculation. For example, I can call it departure delay calc, because I calculated it using the departure time, the real departure time, subtract the scheduled departure time. So I often copy the variable names to get rid of the mistakes. So I can create that data set now, and you can see this is the real departure delay in seconds. So you can see they even tell you the unit we are talking about. So this is departure time, the real departure time, and this is the scheduled departure time. These two have a 2-minute difference, so that's 120 seconds. Same thing, let's find a random one here. So you can see this one actually departed 3 minutes earlier, so the delay is negative 180 seconds. So that's the real data set we are looking at. And using this information, you can actually see like which day has the longest delay, or which airport is often to have the longest delay. So such information can be further checked on after you have this data calculated. And that's about it I want to talk about. Maybe I can create a second video on the lubridate package. And if you have any questions, please feel free to leave it in the comment, and maybe I can talk about it in my next video. Thank you.